So we have some properties of radicals that we've been using to combine and separate roots that have the same index. If we have a root of a product, that's the product of the roots. If we have a root of the quotient, that's the quotient of the roots. Now, when we're working with exponents, we have some rules for when we have different powers of the same variable. We could work out a set of rules for when we have different roots of the same variable. But we have a tool that will let us rewrite any expression that has roots in it as exponents. Instead of memorizing a separate system of rules for combining roots with different indexes, we'll just rewrite our expression in terms of rational exponents, simplify using the exponent rules that we already know, and then go back to radical notation. So how do we do that? We have this expression third root x squared y times fourth root xy to the third, and we want to write it as a single radical. We are told to assume all variables represent positive real numbers, so that means that we're not going to need to worry about any absolute values that might show up as we simplify. So first, we're going to take each of these radicals and rewrite them in terms of rational exponents. Now, if you are super duper comfortable with rational exponents, you might be able to just write this down directly. If, on the other hand, you're still getting used to rational exponents, you can work through this step by step. So we've got the third root x squared y. The third root is the same as the 1/3 power. So we have x squared y to the power 1/3. So we'll have x to the power 2 times 1/3 times y to the power 1/3. That is, we'll have x to the 2/3, y to the 1/3. For our other radical, we have the fourth root of x times y to the third. That's x times y to the third to the 1/4 power. So that'll be x to the 1/4 power times y to the 3 times 1/4 power. So that's x to the 1/4 times y to the 3/4. Now we can use our exponent rules to combine them. Right, so we have x to the 2/3, y to the 1/3, multiplied by x to the 1/4, y to the 3/4. So that's going to be x to the 2/3 plus 1/4 times y to the 1/3 plus 3/4. Now at this point, you can work out that fraction arithmetic by hand if you so desire, or you can use a calculator for it. I'm going to use a calculator for adding those fractions. We've got x to the power 11/12 times y to the power 13/12. The next step, because we want to go back to having a radical, is to write all of our exponents with the same denominator. But in this case, all of our exponents have the same denominator anyway. That'll often happen when we do this, because we're adding pairs of fractions with the same pairs of denominators. So our x to the 11/12, y to the 13/12 is x to the 11th, y to the 13th, all to the 1/12. So it's the 12th root, x to the 11th, y to the 13th. And now we're done if we don't want our radical simplified. If we do want our radical simplified, we notice that 13 is more than 12. So we can split up y to the 13th. The 12th root, x to the 11th, y to the 13th, is equal to the 12th root, y to the 12th, times the 12th root, x to the 11th, y to the 13 is 12 plus 1. So y to the 1 is all that's left inside the radical. Our variables are assumed to represent positive numbers, so we don't need to worry about an absolute value. We have y times root 12, x to the 11th, y. So this is written in terms of a single radical. This is simplified. We weren't told whether or not to simplify in this problem, so either of these would be correct.